Recording in progress.
Okay, guys, if you look at this first question here, what do they want from you? Let's go through this question together, guys. Okay, if you look at this first question here, what do they say? First and foremost, they figure 1.1 and 1.2 shows the speed time graph of two objects, each moving in a straight line. Okay, describe the motion of the object shown in 1.1. How do I describe the motion here? Olivia, what do you write? Good. The object is moving at constant acceleration. Object is moving at constant acceleration. Okay, this is the first thing I'm going to write because you can clearly see that the gradient is constant, right? Otherwise known as constant acceleration. Okay, and what do you write for the second one? Is what do you write? So moving slower. Why is that wrong? Which part of this graph is moving slower? No. Okay. What do you write for the second one?
Initially, the air resistance is very small, but the object accelerates, the air resistance increases. Eventually, the air resistance balances the weight and set the constant speed. Like the terminal velocity.
This answer is going to be for this, by the way, but you got the right idea. Okay, but that's wrong. What do you write? That's correct. It's definitely accelerating some more. Oh. Slower than the other object are not exactly right. Guys, listen up. This part here, you're supposed to explain in terms of its acceleration. Guys, first and foremost, I want to ask, right? Is this thing decelerating? Figure 1.2. It's not decelerating, right? I know for a fact it's not decelerating because the speed is slowly increasing more and more and more and more, right? But you can see the graph is curving, right? Let me ask you this, guys. In this curving graph, is it increasing gradient or is it decreasing gradient? This graph is clearly decreasing gradient, right? Just now we said that in the speed time graph, the gradient represents what again? Wait, what does the gradient represent? Yeah, so if I have decreasing gradient, it means to say I have decreasing acceleration, right? You're supposed to mention this in your exam, guys. You're supposed to say that the object is still increasing speed, moving with increasing speed, but decreasing acceleration, guys. Object moving with increasing speed, but decreasing acceleration. And then notice how they allocate 3 marks for this. The one on top, they only give 1 mark. The one at the bottom, they actually give 2 marks, guys. Okay. And then the next part here is the important one. On a day with no wind, a large object is dropped from a tall building. The object experiences air resistance during its fall. State and explain in terms of forces acting on it how the acceleration of the object varies during its fall. So right now I have an object falling down with air resistance. What's going to happen? Wait, if I have an object falling down with air resistance, what's going to happen? Stay there. Okay, stay there or stay there就是没有动的。Not exactly what I'm looking for. 对，以后试试看这些东西。The average increases the acceleration is oh, this is actually correct. Is on it? Wait, this is actually very correct. Very good. Guys, you have to imagine that once again, this part here, guys, you're supposed to literally look at this part here. Alright, initially this object falls now. The only thing acting on it is its weight, in other words, gravity lah. Right, so it accelerates. As it increases in terms of its speed, the air resistance increase. So the acceleration slowly decreases. That's why you can see that the acceleration slowly decreases here. Eventually, the upward force will be equal to your downward force. When this happens, terminal velocity is reached where there is zero acceleration, guys. You understand what I'm talking about? This is literally that, right? In terms of the formula. So, hey, wait a minute. Now that I look at it, do you copy everything down from here? Yeah, at least you were right. Yes, very good. This is exactly what you're supposed to write, guys. You're supposed to say that initially. So, is my handwriting too ugly? Okay, I'll type next one. Okay. As the speed of the object increases, upward air resistance increases, causing the acceleration decrease. Upward forces E equals shit. Okay, writing actually equals to the downward forces. So the ratio except 0. Simply is reached. Shape. Okay, no more writing. It's gonna be something. Okay, guys. This question very often we come up in the exam. You actually need to imagine what's going on in terms of the object forces. Maybe I write this down. Okay, new glasses. I repeat, guys, this question really often comes out in the exam. You need to know how to write this, the whole thing on my brain. It's worth 4 marks. It's worth a lot. Okay, everybody. For most of you guys that did not attend the next question, I need you all to start attempting it right now. Question number 4. For you, this is wrong. The angle is wrong. I'll send to you. Okay, and so the runner runs at a constant speed of 10 meters per second 嘛，那说你这个开头是对了吗？这个很 constant speed 哦，这个不是 increasing speed 那种，我们这个我来那个，okay 啦呀 ，Let me see。And building maybe a better. For this, I mean, definitely for really good simplified. Velocity alone is equal to displacement, and this is literally both the same, almost the same thing. Just that this thing has direction. Maybe you know about stars, so what's the main difference between living? If let's say start from position A to position B to position C, this is distance, right? But displacement only takes into account the starting point to the ending point of the same direction. So this is the start, this is the end, this is displacement. You get that? This part here with displacement. So velocity is literally this just with direction. Yeah, acceleration shape of this follow. Alright, function to me. Which part here I need to know these components. Every part we can get the but we still need to say it's changing to near acceleration. What is the gradient? Why is the gradient represented this that? Because have you learned about gradient in mathematics? It's changing y or changing x. So this is the change y actually changing. Changing y to be distance, changing x to time. This is essentially the line. Yeah, so that's a literally gradient is equal to changing y over changing x, which is y2 minus y over in this scenario, the y gradient changing distance, x gradient changing time. That's why it's represented. Yeah, it's the same for this one. So change in velocity, same thing, change the gradient, but then change y over changing x. Right, change in y this time here will be change in velocity over the change in time. It's essentially different. That's finally representing the acceleration. You're not supposed to remember answer because they couldn't really talk back the graphs later. So we need to learn when to use the gradient representing. And why is the area representing the distance there? It's not that simple. I mean, area is based aspect. Right, in this scenario, it will be velocity multiplied by time. Can you see? Right, and this velocity multiplied by time. Velocity multiplied by time is displacement. Can you see? That's why the area represents the distance of displacement. Again, fully configuration. This one. What happens is right. If object will have resistance, affects the spread to the gravity is roughly 10 meters per second. So we need to say each second after time, speed increases. But in this scenario, it's falling with air resistance. If the object is falling with air resistance, there will be an upward response that slowly increases as your speed increases. That's why we can see that hydraulic the velocity is the same line. The acceleration is slowly increasing. You see that the gradient is slowly increasing. Like that's how the acceleration is slowly increasing. Eventually, it'll time. Because there's zero based on the process. Okay, and this section was fascinating. Why is this the same as not? Yeah, so. The runner runs at a constant speed of 10 meters per second during the first 5 seconds. In this constant speed, this part is definitely not, if this was true, or this one is accelerating, so you're already the figure out of the line. Yeah, good. Then the car is increasing from 0 to 25, and this is the correct one. Graph again and try a calculation. This is on the nose. Look here. The runner is running at constant speed of 10 meters per second. What's the important? If we take the answer now, right? Isn't this a speed time graph? Isn't this a positive gradient? Wouldn't this mean that it's accelerating? To the north? Now, the net. The student travel by the runner. It's not that I'm out, I just become recommending. Or speed distance equals to speed times time, right? 它speed 是0，现在周末是20，有看到白的蓝。哦。Actually, it's a thing. Same thing. Okay, like that. Are you? Great. Right, yeah, that's just the story. Alright. Yeah, you should demonstrate I very. This is a features from 0 to uniform uniform English is a constant acceleration, which are straight line. Ôi, cái người này, mình biết là nào. Thế là, thế là对. But 这个怎么搞的？中公司20%。哎，这样子的另外。Wait, 这个是 speed time graph 来的 right? What are you looking for right now? We got distance, right? Then if I want to find a distance in the speed time graph, what can I look for? Ah, what? Area under the graph 啊，对吗 ？Area under the graph 是这个理论。So how do I find the area of a triangle?
Right. I mean, on your web,
啊，
那你这个，
是吧？ half times big type man. Same thing for you also. Define the area under the graph, right? Wait, what? I get this pattern. Where did this come from? Then why is it at 1? Why not here to 1 to the 3? Still big for 5 seconds. I know it should be this straight line. Just be here. Oh. And then this one also, you find the area under the graph, right? This area is 35 times 5. Don't forget your half. Hey, for you all find the area under the triangle, don't forget your half. Pass out. How do you get this repeat? Okay, well. Okay, good. Most of you guys did already. And most likely you got the last question wrong, which is not 2 seconds. For everyone who wrote 2. Alright guys, pay attention. You're supposed to do something like this. At a sports event, a champion runner and a car takes part in a race. Not a stupid thing to say. A runner runs at a constant speed of 10 meters per second. This is your first information, right? It's moving at 10 meters per second at a constant speed, right? For some reason, I don't know why, most of you guys like to draw like this and then start a straight line here. I know why most likely you thought about something like this. You think that he must have started from 0, right? Because he's at a race, right? Then if that's the case, right? How do you know after 1 second only you run at full turbo? Why didn't you run at here then only full turbo or here then only full turbo? No. Okay. So you're supposed to just draw one straight line only, okay? Don't try to reason or whatever, because logically speaking, this guy is already not supposed to run faster than a car already, right? So don't try to reason or whatever, it should be just one straight line. Then the next part, most of you guys got it correct. It's 0 to 25 at uniform rate. Uniform rate means to say constant acceleration, guys. Constant acceleration, which means to say you're just supposed to find 25, which is somewhere around here. Then you just draw one straight line. Right? Which you end up somewhere here, which is the confusing part. Once again, they ask you to find the distance traveled by the runner, which I don't know how the thought process for most of you guys did, but the thought process should be something like, oh, distance, oh, speed time graph, oh, it should be the area under the graph, right? Which in this case here should be 10 multiplied by 5, which is obviously 50 meters. The thought process should always be the area under the graph, not just the number, right? And same thing for the car. For the car, you want to find the area travel also, right? Which is this here. Oh shit, color is too same already. Which is this part here, right? Right. Then you find that, oh, I'm supposed to find the area of this triangle. And you realize that, oh, area of a triangle is half times base times height, which in this case here will be 5 times 25. Right, then you'll get 62.5. Is it? Yeah. 62.5. Okay, then this part here, the time which the car overtakes the runner, most of you guys see this graph, you see that, hey, this point is when the graph overtakes all. So it must be overtaking each other, right? But if you think about it, guys, I want you to think about it. In order for anyone to overtake each other, assuming that, let's say this is the starting point and this is the point where they overtake each other, they must travel the same distance at that moment to overtake each other, right? Can we say that? Right. If I look at the area under the graph, this is the, oh shit. If you look at the area under graph, this is the point of the car, right? This is the area of the runner, right? Which one has a higher area? The runner of the car or the car has a higher area? This is the car over.
Oh, you mean that?
This is the runner. Which one has a higher area? The runner lah, right? If I were to calculate the area, the runner is 20 meters and the area of the car is only 10 meters off. So they haven't overtaken each other, right? In fact, if anything, for some godforsaken reason, the runner is faster than the car. Now, so how do I find when will they overtake based on this one? Come on, let's get creative. How do I know that they are overtaking each other? Okay, let's assume it's 3 seconds. Okay, if 3 seconds is here, right? Once again, 3 seconds, the runner is at 30 meters. And the car will be half times 3 times 3 seconds, it will be somewhere around 15. Still not long. 45 times divided by 2, it will be 22.5 only. This one still have not overtaken yet. 5 seconds. Okay, let's assume that is correct. 5 seconds, it will be 50 times 5, which is going to be, wait, this won't be 5 seconds is here already, right? Here will be 50 and here will be 62.5, right? At 5 seconds, the car is faster than it's in front of the runner already. So the only one left is 4. Right on. Oh wait. Why do I know it's 4? Because if you think about it, guys, shit. If you think about it, at 4 seconds, right? This is the triangle, right? Right, and this is the rectangle, right? This part is a rectangle. Actually, I should use a different color. Okay, this part is a rectangle. Can I put this part here into this part here? Then it will balance off already, right? And if you don't want to do it creatively, you can do it mathematically. If I do it mathematically at 4 seconds, here, here will be 40, right? For sure. And then the triangle will be 40, sorry, it will be half times 20 times 4, right? Which is also going to be 40 meters. Can you get it? Everybody, this is important. Don't guess based on this, which I see literally every one of you guys did. It's not going to be 2 seconds. Okay, so your answer should be 4 seconds. Based on the formula. This was the runner, this is the car. Okay, everyone, please proceed to the next question.
Oui,是在哪里？你还是这一个给哪里中间？你叫他看呢？哎， Right. This is for evidence. Where is actually edit? We like probably. Right. Yeah. So for distance, right, which is what? In the free hand graph, how to find the distance? Or which area is it? You know, 然后来啊，全部你要的快那个吧，那个这种感觉就是什么？对，哎，这个说下边的一个人放一些货币，对吧？The acceleration behind what we find acceleration again. Okay. Right. So okay. So I want second ma, I want second. Right. So that it is. So it is. You need to see part you kind of green, such as part 7, 20, and you should see a green on the business. How many boxes are there? Or how many boxes represent 200? 5 boxes represent 200, right? Right. Right now, they have 5 boxes represent 200, and 1 box represent. So how many boxes are there right now? 2 here. Oh, so 3 boxes how much? Go do it step by step. Now you learn to get the 125 meter acceleration. I think that's correct. Right. So you use that. Maybe you use it. Hey, back to here. I think the people were lining up on this bit there.
Are you guys online? Company.
So how to be right for? God, 真的有给我。对，然后
那这贵的几百千。
你知道为什么吗？去 Starbucks 他们那 camping 那边，那多少钱？你可以理，他们在 camp 这我那个 Starbucks 嘛，我 Starbucks 嘛 ，Blackpink and Starbucks 嘛，what the hell，真的会有人买的咩？还去那边 camp 呢 ，camp overnight 呢？
got a 10, got a 10.
Yeah, I'm like, what the fuck？有这样子的东西来的吗？是啊，现在我看见
What's the campus?
啊，
What's the campus?
他不是
I
去吧，拜拜，pay your problems away。对，这个对于 acceleration 哦。可以，可以。Which part is that? Okay, I need to know what's it on. Which part is something so Look. Are we all looking? Look, what do they have to do? Actually, the other you know that they knew. He's looking at the JD. How? Look at acceleration, right? In the 3-time graph, 3 times acceleration again. So which component of a 3-time graph represents acceleration? Yeah, the gradient of the 3-time graph represents acceleration, right? So I'm looking for the gradient at this point here, right? Right, so if I'm looking for the gradient here, what do I do? I need this coordinate here, right? Right, what's the coordinate here? Comma, or what's the coordinate here? 0, comma, or so with these 2 coordinates, can I find a gradient? I'm going on. What do you mean? Do you know like a wait, you know, and then I got even really confused. I the ground. I got the ground. I just like a so you're looking for this area, right? Go on, I go. So you must check. Yeah. So you found this triangle. I need this triangle. It's what who's not mother. We do line, we should have who's how much. No, wasn't really bad. Now I hear and how look at each offer when oh. Sorry, go back to changing my access condition. Right? Any these can what? No, X, big X loan. Sunscreen 點有嘢啊？
That's not.
Because you don't pull cool, no recording 俾你整壞咗。我啲 sharing screen this thing. Yeah, thanks lah. Thank you. Can fuck. Sure. Okay, everyone, let's go through this question together. Since I see some of you guys are already a bit stuck. Okay, guys, if you look at this question here, guys, what do they want from you? They say that a rocket shows a rocket powered sled traveling along a straight line. Right, it's traveling along a straight line, and the sled is used to test components before they are sent into space. Not important. Then you have this graph here. This is a speed time graph. I keep saying this over and over again, guys. You need to know what the gradient represents and what the area represents. As soon as I see it's a speed time graph, the thought process should be, oh, the gradient represents the acceleration and the area represents the what? Yeah, the distance traveled, right? So from here, okay, this one I established already. Then after that, the question says, on figure 1.2, mark a point and label P to indicate a time when the acceleration is not constant. Which part of it is not constant? What? No one drew a P. Which part of it the acceleration is not constant? Where? How do I know the acceleration is not constant? Like this. Flat line like this is zero acceleration. This one is curving. Right? Why is it this part that is the P? How do I? Good, because at this here is increasing acceleration, right? So this is not constant acceleration. This part here straight line, constant acceleration. This part here may be straight line, also constant acceleration. Only this part here where the curves are with. It's not constant acceleration, right? Then after that, they ask you to calculate the acceleration at time equals to 1. Right? If I'm looking at time equals to 1, how do I know that the acceleration? Once again, I'm only focusing on this part, right? Which I want to find the gradient of this graph, right? And I know that the gradient is change in y will change in x, which in this case here, I first have to find how much each box represents. For those who do not know, guys, if you don't know, you can count the boxes one by one. 1, 2, 3, 4, 5. 5 boxes represent 200. This one here is 3 boxes, right? So 1 box represents 40. 3 boxes will represent 120. Right? So from here, it's literally 120 minus 0 over 1 minus 0, which will give you 120 meters per second square. Don't forget to write your units. Okay, if you don't write your units, you are wrong straight away. Then they ask me to find the distance traveled from one. Right, distance of, oh my god, distance again. I've already established this, that the distance is the area mark from 1 to 2. Here is 1, right? Here is 2, right? That means I want to find the area here, right? So once again, there's literally multiple ways you could do this. What Olivia did was she did something really interesting. What she did was she found this triangle area, right, which was half times base times height, right? Then she minus this triangle area, which is half times base times height also. Then you can find it. Alternatively, if you don't want to do that, you could do what I usually do. You could separate this part into a triangle. You find the area here first, then you can find this rectangle and find this area also can. Alternatively, if you don't want to do that, which is what I will usually do, right, I'll straight away find that this is a trapezium, right? Trapezium is A plus B over 2 times C, this A is 120, right? It's 120 ma. And this one is how much? This here is 240. This here is 1, right? So if I press that into my formula, in my calculator, it will be like 120 plus 240 divided by 2 times with 1, which I'll get exactly 180. You get it? Yeah? 啊 ？C 啊，这个是 C， 因为这个是 A 嘛，这个是 B 嘛 ，A B C。OK，A 和 B 是 parallel 的，永远可以记得，他们两个是 parallel 的 ，C 是那个 extra 的那个。OK， and then after that, the resultant force acting on the sled remains constant during the test, such as why the acceleration of sled is not constant. This is the story of Mud basically. Okay, guys, listen up. I'll dissect what the question means for you. They say that the resultant force acting on the sled remains constant. By right, if we follow the F equals to MA formula, a constant force with a constant mass should have constant acceleration. Right, by right. But this one here, they say that a constant force, the acceleration is not constant. And if I look at this graph here, the acceleration is increasing or decreasing. Increase or decrease? Well, I really didn't hear. No, I seriously didn't hear. I'm not. Increase or decrease? Increase, right? So I know that the acceleration is increasing, but this is the same. In order for this to happen, what must change with the mass? The mass must increase or decrease for the acceleration to increase. I repeat my, sorry? Good, the acceleration should, the mass should decrease. I repeat, so if I put this in numerical number, let's say force is 100, the mass was 10 and the acceleration was 10, right? Right now, they say that the force is the same, but my acceleration increased. Let's say increase to 20, my mass must decrease, right? Right. In order for my acceleration to increase from 10 to 20, my mass must decrease from 10 to 5, right? Then only my force can be the same, according to my F equals to MA formula. Right. So in this question here, they are literally testing you on this. And one very interesting way you can remember this is, have you guys ever seen rockets being shot into space? By the way, you didn't tell you this story about it. Last time I dreamt that some barber helped me cut hair like this. And I'm like, the fuck? Why do you cut my hair like this? And it's like, I did it on purpose. I said, can you come back? And say, no, I cannot. Then he started chasing me with his knife and I start running. Now I was telling my girlfriend this story this morning. I said, you know, it's like a nightmare, you know. And then this damn barber cut my hair with, like my hair is here long, here short. That's why I thought this is long, here is short. Then my hair here is very long. Anyways, every time I look at it, I was so. Anyways, for those who have seen a rocket ship fly up before, guys, you see like rockets being launched into space before, right? If you ever notice, let's say this is the key component of the rocket, right? They usually have the thrusters here, right? But before they use this thruster, they usually have other thrusters connected to the rocket ship one. I mean, it's a very poorly illustrated rocket ship thruster, but have you seen like on the side of a rocket ship, they always have other thrusters attached to it? So initially, when they shoot this rocket into space, first they'll burn this part. They'll burn, use up all the fuel. These things are literally just to hold fuel. Then they'll eject these two things on. They eject these two things out. Then after that, they start burning this part. Then the fuel finish already. Then they eject this part also. Right. Then they will most of it be in space already. Then when they come back, right, usually they'll use like this part here to come back. Right. So this is the same concept of why the acceleration can increase, because initially this thing is damn heavy, right? But as I burn more fuel, right, the mass decrease, right? And then I'll eject this thing out so it can accelerate even further into space. And then finish burning this fuel already, then I'll eject this shit also. Then this thing will be the only thing that goes into space. and then they come back. When they come back, sometimes they even reject this whole thing also. Oh shit. Sometimes they will even reject this whole thing also. So the time when they see it come back, right, it's always just like one small little pod that comes back with a stupid parachute thing landing into the season, right? It's because they want to decrease the mass as much as they can. Okay, so this is like, and this also is applicable for the Mark Rampids. So you guys know what Mark Rampids are, right? The Supermans of the highway. You don't know, really? You know those guys, right? You know those guys that they ride the motorcycle and then the whole body is like leaning down onto the chair and then they fly like Superman like that. You guys never seen before.
Oh, those like those could be people the YouTube TikTok.
Yeah. The YouTube ads.
The one also who put the head on the seat and then
Yeah, then they're flying like this one. So let's say this is the seat, right? The legs is like this one. And then they ride there all the way down. One. You guys seen it before, right? These Mark Rampids are they also men of physics, man. I tell you. You know when they pump the fuel, they'll pump to like maybe one block of fuel only. Then they'll start riding it. Because why? If you pump it very full, right, the motorcycle becomes heavy. You won't go as fast one because the acceleration is not as much. So they pump one block of fuel, and then you can see that fuel indicator is always blinking when they're going at maximum speed. Bling, 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 because like all the way until they die. Literally. So yeah, this is one of the interesting things. Okay, so from here, having said that, you're supposed to write this down, guys. Just why the acceleration of the sled is not constant because the mass, because the mass of the sled is decreasing. Or you could say because they finish up using the fuel, or you could say that the fuel mass is decreasing, or something along the lines that is the Okay, guys, please attempt the final question before we end it. Anya, you know it's your first day here, right? But I need you to ask me if you don't understand, okay? What are you什么情况的是吗？做成绩了，这才是 right working line。以后 excellent，什么只是会当别人。Once again，真的是 speak mind right？那只能找什么？那找 distance，只能找 distance in the six。
Yes, I can help. Right, well, it is like house. Also, the yeah, even in European, it says that traveling is with blah, and both the speed and the velocity is the format between the transfer. This is the keyword of this, and this means. Hey, for those who are stuck with the first question, guys, the keyword is that both the speed and velocity remain constant. That's the first keyword for your first question. And who's explain how you think the motion of the object is. That's kind of how it works. Okay, what big? For those who are stuck with the first part, let me tell you what to do. Nice. Like I said, the keyword here is right. The speed and velocity of the object remains constant. What's the difference between speed and velocity again? What's the difference between speed and velocity? One is a scalar, another one is a vector. Very good. What is a scalar and what is a vector? Right. One has magnitude, the other one has magnitude and direction. Good. So if I say that both of them remains constant, the magnitude for sure the same, the direction also the same, right? It means to say the object is moving in one straight direction only. Right. In what scenario will the speed and velocity not be the same then? For example, if let's say I have an object, let's say this is Earth and this is the moon. Right, the moon rotates around the Earth, right? There is the moon, and this is the moon also, and this is the moon also. Okay, even though the speed of the moon at these four positions is the same. For example, I don't know what's the speed, 100 meters per second, 100 meters per second, 100 meters per second, and 100 meters per second. I can say that the speed is all the same, right? But I cannot say the velocity is the same. Why? Why can I not say the velocity is not the same? Besides being the reason I told you so. Why? Why? Very good, because the direction is not the same, guys. This point here, the direction is this, the direction and this point here is this and this. Because the direction is not the same, then the velocity is not the same already, because velocity and direction. The magnitude is the same for speed and velocity, but the speed and velocity is not the same because the direction is different. So if you have that in mind already, right? Look at this question, it will make a little bit more sense, right?
So if they say that both the velocity, the speed and the velocity remains constant, it means to say the comet is moving in one single direction only. 明白嗎？咁多位 So we are supposed to say comet is moving in one direction. And then the next part. The next part, once again, they ask for the distance traveled between 0 to 6. Wow! Again, distance traveled in a speed time graph. Which component of a speed time graph tells me the distance? Good. So it's literally, you need to find where the 6 is, right? It should be somewhere around here, right? This will be the 6, right? Trying to find the area here, right? How much is this? This part is how much? 360. 36,000. Right, 36,000 ma. Right. So if I want to find the area, it's going to be literally. How do I find the area? Very good. Press on your calculator, you'll get some big number. 1/6 blah blah blah. What's the units? Meters, very good. Then after that, they say explain how the graph shows about the motion of the comet during the 6 to 10 second. 6 to 10 seconds is where? 6 to 10 seconds is literally here, right? Around here lah. Oh shit. Why did you go straight line? Around here lah. Right. How do I explain this? What's going on? You'll get 1 mark for that. What's going on here?
Evidence.
Air is in your head. Wait, right there, the. And what do you write? What do you write? You'll get 1 mark for that. Now, obviously, the object is decelerating by 2 marks. So how? Hey guys, once again, if you see that this object is this straight line? It's curving, right? If it's curving, I need to explain whether it is increasing deceleration or decreasing deceleration. Based on this, if based on this graph, increasing or decreasing deceleration and why?
Increasing deceleration.
Sorry?
Increasing deceleration.
Very good. Why? How do I know?
Because increasing deceleration lah.
Why can't it be decreasing deceleration? How do I know that this is increasing deceleration? Based on what? Not gut feeling. Yes, curving lah, right. Guys, if you want to know whether if you want to know whether it's increasing or decreasing acceleration, you need to ask yourself, is it becoming more steep or is it becoming less steep, right? If I look at this part here, initially it's like this, right? And then right now it's like this, right? It's becoming more steep, right? So it's increasing deceleration. The gradient is increasing. Okay, which what you're supposed to write. Comet is decelerating at increasing rate. Then after that, they ask you to once again find the acceleration of the comet at 11 seconds. Which part of the graph tells me the acceleration again?
Gradient.
Excellent. So 11 seconds is here, right? Shit, where is 11? Here's the point. Okay, it's 11. Now, guys, if I pay attention, this is also very commonly asked in the exam. Some students, you know what they'll do? They'll find the coordinate here, right, which is going to be 11 slash 18,000, right? You know what the students will do? They'll tell me it's going to be like 3,600 minus 18,000 divided by 11. Some students will tell me like that. This working will only be true if the graph is like this. Right, then it will be 3,600 minus 18,000 over 11, which is clearly not the case here. Okay. Pay attention now. If your exam, they only give you one specific point, right? You're supposed to either find the gradient from the graph here, understanding that since this is a straight line, the gradient here, here, or here will all be the same. That's why it's called constant gradient. Or you are asked to find the tangent. Let's say, for example, in an alternate scenario, they ask you to find the gradient or they find the acceleration at 8. 8, this is a curving graph, right? Curved graph, there's no gradient on. You need to draw a tangent. You know what's a tangent? You guys know what a tangent is? A tangent is a straight line that touches the point one time only. And then after that, you need to find the coordinate here, you need to find the coordinate here and do the triangle method to find the gradient. But this question don't need that, right? So for the sake of understanding right now, I just need to find the gradient here only, which is this straight line. Which is this straight line here. Okay, so I want to find a straight line here, I need to find the coordinates on. Here is what? I find the coordinate here and here, probably. Just one missing 12. Okay. 12 and 12,000 now, guys. Right. And it's just like y2 minus y1 over x2 minus x1, all right, y2 minus y1, we got x2 minus x1, which in this case here will be 18,000 minus 12,000 over 11 minus 12, which will give me negative 6,000 straight away. And finally, the last question is quite a logical, common sense question. So this is what happens to the comet at 12 seconds. Wait, at 12 seconds, it's here already, right? What happens to the comet? Huh? Right, comet already smashed into the ground already. That's why it's not moving anymore. Or you can say that the comet has landed into the ground already. And that's your final question. Okay, everybody. This chapter is very important now. Next week, when we come back, I'm going to move on to a new chapter, which is much easier. It's basically density, mass, and weight, right? But we'll come back and revisit this chapter because, like I said, this chapter here, 80% of the time will come out for the first question in your paper form in your real exam. So you must know how to do this motion time graphs. It's all just playing around with the gradient and the area only, right? Okay. That was it for today, guys. See you next week.